Hello, I'm Varun from Hammer Missions, and in this particular video, we're going to be looking at how to thermally and visually map a hotel using drones. Once we've got the thermally and visually mapped hotel, we're going to actually also use AI to find defects and quantify how much issue or deficiency do we have with this particular hotel. Let's have a look. Hello. So as we said before, we're going to be thermally and visually mapping a hotel in this particular video, and we're going to walk you through the flight planning process, the 3D modeling process, and finally the AI analysis process. Let's have a look. Right, so we're going to start with the flight planning as usual. So what you see on the screen is essentially the hotel, and you might notice that the hotel actually has some form of sort of a roof, actually a double roof system going on over here, where we're not only looking at the main roof, which is sort of over here, darker in color, but we've also got this sort of red roof in the bottom over here. So it's going to be really interesting to see how we map all of those. And just from the visual of the Google Maps itself, I can tell that there are all these sort of water-related issues that we might be able to see more clearly thermally. Let's see what happens. So let's start with our flight planning. So what we're going to do is we're going to set up a new folder. So I've got a folder set up, and I'll set up a new mission file. So I've got one set up over here already. So I'm going to go into that, and basically I would change my location to the hotel's location, which I can do from here. But I've already done that, so I'm not going to go into the specifics there. So the first thing I want to do is I want to capture the roof, and to be able to do that, I'm going to go into my missions menu in Hammer Missions. Just out of interest, if you don't know, I'm using Hammer Missions. Hammer Missions can be used for flight planning, 3D modeling, and AI analysis, the end-to-end workflow when it comes to sort of building inspections. So basically, I will start by creating a mission plan for the roof. And since I want to be able to sort of capture images of the roof looking down and 3D model the roof, I will actually start with the 3D modeling mission. I could also choose a mapping mission in this particular case, and I'll come to that in a second, but I'm going to start with 3D modeling. If you're not sure how that all works, you can always go into the tools tip and figure out all of the description. But for the meanwhile, I'm just going to choose 3D modeling, and I'm going to start drawing a polygon around the area of interest. So I'm interested in capturing the roof, and I'm going to draw a polygon around it. What I will do is I will ensure that I am sort of capturing a little bit more than the roof, because we always want to have a little bit more extra coverage, because we might have offsets to Google Maps when the drone actually flies this mission. Right, so once I've marked my polygon, I will see a double grid flight plan generated. So these blue lines that have just come up on the screen, these blue lines are actually showing me the flight path of the drone. So if I was to press the play button, we will notice that actually you see a flight path for the drone sort of come up both in 2D and 3D, which gives me an early indication for what the flight path is. Now, this flight path is actually just the default flight path. It doesn't really have any of the important properties that we want to be able to map this hotel. So what we're going to do is we're going to go into the settings option for this particular flight plan, and we're going to choose all of the different properties that give this flight plan a better fit with respect to what we're looking to capture. So essentially we want it to be as fine-tuned as possible so that we get the right data in the end. Because ultimately drone flights are all about data, and if you don't have good data, you basically don't have anything. So let's have a look at the camera type. So camera type is the type of camera we're going to be using for this mission. So we're going to be actually using the Mavic 3 Enterprise Wide, so that's correct. And for the thermal side, we're actually going to use the Mavic 3 Enterprise Thermal, so we'll come to that in a second. But basically, we've got the wide camera chosen, which is good. What we want to do is we want to set the altitude for this property, which we'll come to in a second. We want to set the offset, ground offset. We want to set the overlaps, flight direction, all these different properties. So to be able to determine the altitude, what we need to do is we need to actually go to Google Maps and have a initial early idea as to what the altitude looks like. To do that, let me just go into Google Earth quickly. Right, okay, so we're now back and we're looking at a 3D model of the property of the hotel in Google Maps, in Google Earth. So we're no longer in Hammer Missions, we're in Google Earth. And the reason why we've gone to Google Earth is because we want to be able to actually look at what does the property's altitude actually look like. So to be able to determine that, what we're going to do is we're going to actually use the ruler tool on Google Maps to have an early idea as to what the property height is. Now, assuming we are taking, so it really depends on where we're taking off from. In this particular example, we have to realize that actually this property actually has a double roofing system. So we've got to take into account a little bit of both to understand what the total height of this particular mission should be. But just to start with, what we can see already is that this particular part of the property forms a bit of a square. So if I was to measure the roof from here to here, that gives me an early idea as to what what the height of that particular property is going to look, or the height of that particular level is going to look like. It's going to be about 30 meters according to Google Earth. Okay, so that's good. So that's 30 meters or roughly 90 feet. And if I look at this particular section here, I can also identify the square. And so I just need to use my ruler tool again. And if I just go in there, I should be able to sort of mark up. So that's another 10 meters on top of the original. So that's 10 meters plus 30 meters from here. So we've got about 40 meters. 120 would be the right altitude for this mission. So going back to Hammer Hub by Hammer Missions, we wanted to put in the altitude. We know 40 meters, that is 120 feet is the altitude. But just because we want to be safe, we can go for 140 feet. So we are still quite far above the property in terms of capturing this data. Ground offset, so that's the offset on the ground. So this is important if you're capturing just the roof. Since we're capturing both the roof and the facade, we could sort of ignore this, but actually for really good data, we want to ensure that we are taking into account the height of the building. So since we are flying from the ground level over here, and the building's at 120 feet roughly, we're going to actually go for 120 feet so that we tell the software that we are actually flying very close to the ground, and to be able to get the right GSD, we need to be able to fly with that altitude in mind. Now, what we notice by going to 120 feet is that this particular building has become a bit too dense. The flight plan has become a bit too dense. And so what we want to do is we want to make it less dense. And therefore, there is a trade-off to strike here between the ground offset and how dense the flight plan will be. And also, we've got a GSD of 0.16 centimeters per pixel, which is actually quite detailed. And we really don't need that level of detail for this particular property. So what I'm going to do is I'm going to try and reduce ground offset so that we still have a healthy amount of ground offset in there. But I don't have so much ground offset that it completely kills the metrics of this mission. So this is looking a bit more healthy. We've got 0.5 centimeters per pixel GSD. We've still got ground offset in there. It's about 200 images, one battery, and an 8-minute flight. So this looks pretty good. So we're going to go with that. And what we're going to do now is we're going to actually look at the front and side overlap. So that's set to 80%. We can leave that at 80%. If we had wiggle room, we could go to 70%. But for this particular mission, that looks pretty good. Flight direction, that's fine. Gimbal tilts minus 70 degrees. So this is quite important. So when we're doing a 3D modeling mission, it's really important that we keep the gimbal tilt to be negative 70 as opposed to looking straight down. There is an argument to sort of like capture straight down if you want to do just a flat structure. But if you're doing a 3D model and you want to pick up all of the different areas on the roof, including some of the elevated areas, having a gimbal tilt can be really important. Flight speed, 5 meters per second, that's automatically calculated for us. You'll notice that if I increase overlap, the grid becomes much more dense and then the flight speed drops. But if I reduce the overlap to 80%, the flight speed increases. So basically, Hammer Missions automatically calculates this for us, so we don't have to worry too much about what is the right flight speed, because it already takes into account the shutter speed of the drone and all the different metrics in terms of giving us the best flight speed possible. Smooth corners, yes please. We want to make this flight smoother and faster, so we would add that. And reverse flight path, well, we know the flight path is going to start over here, so this really depends on what our takeoff location is. If you're flying from the back of the property over here, then starting the flights here would be a good idea, so that we can view the drone as it starts its flight. Or if you're starting the flight from the front of the property, then we might want to reverse the flight path to be able to give us a different point to start the flight path from. So that really depends on where you're starting the flight, and that's more of a pilot optimization than the data optimization. And finally, show plan pictures. So if you wanted to have a quick look as to where the images will be taken, we can turn on that little toggle over there. And we see all these blue dots that indicate where those images will be taken. And that just gives us more reassurance in terms of how the data will be captured. We've got about 200 images in this flight, and we're good to go. Let's press play to see what that would look like, the flight plan. And we can see that in 3D, and that gives us a bit more reassurance in terms of how that's going to be captured. Now, we're also going to do a facade flight plan. So we're going to go back to our missions folder, and we're going to add a facade flight plan. So we go into facade, go into the same mission file as before, and then we choose facade mapping this time. Now, once we choose facade mapping, you can basically choose to circle around the property. So basically mark the edges of the property as the edges that need to be captured. And basically Hammer will generate, once you press OK, it will generate a flight plan around the property, looking into the property. And this is really important if you want to capture the facades really well. So Mavic 3 Enterprise wide, once again, width first, basically fly around the property first and then reduce in altitude. Top altitude, so we have identified that we're going to start at 140 feet. And we could do a few circles around the property. So let's go to 100 feet to be able to see how many circles we're doing around the property. So, admittedly, it's not a perfect circle. It's more about sort of following the geometry of the property. Gimbal tilt. So we want to give this a -45 gimbal tilt. So what's really important in your facade missions is that when you're capturing these facade images, you want the roof and the facade in the images to overlap with each other. And therefore, having a gimbal angle of -45 is really important because that ensures that overlap is in place. Horizontal distance, so we're at 50 feet right now, which is arguably quite a lot. So we could reduce that distance to, let's say, 30 feet and then have a tighter flight plan where we're looking at the property from all of these different angles. And then finally, what we will do is we will just adjust the flight plan so that we have this last corner covered. To be able to do that, we just move the last point over here and just add one extra layer of capture where the drone is basically doing one more point of capture in terms of closing in on itself. And that's pretty much it. The overlap is 60%. We could go to 70 if we wanted, but for this particular mission, we could stay with 60 as well, given the fact that we're going to have quite a lot of overlapping orbits. But if you wanted, we can go to 70%. We look at the images here. It's gone to 310, which is fine, but it seems like right now we're taking more facade images than we're taking the roof images, which is fine because it's a relatively tall building. I wouldn't say it's probably wider than it's taller overall. So I think that sort of allows you to govern how many images you'll have for the roof and how many you'll have for the facade. And let me see. So let me see. Let's go back to 60% to see 200 images. That looks about right. So 200 images for the facade and 200 images for the roof. I think that's probably where we want to be. And once again, we press play and then we are able to see the flight plan in 3D. So now this is quite helpful because obviously we want to be able to see how many rows of flights are being done. Seems like we're doing 4 rows of flights over here, and maybe that's an overkill, and maybe I just want to do 3, so I can adjust the bottom altitude to be 110 degrees, and that gives me actually 3 lines. It still gives me 4 lines, in fact. So it seems like the flight plan is quite spaced out, and if I go to 120, we might get to a place where it's actually only 3. Now, what we need to remember is that 140 was the altitude we were using when we were actually above the roof, and the building was actually at 120. So what we really want to do is we want this to be 100 as we had before, and we want this to be 120 because we want to be capturing slightly above the building, but not that far above. So this is really helpful in terms of understanding what is the right top and bottom altitude. All these parameters can still be tweaked on site, but at least you have the initial best guess, which reduces the time it would take to set this up on site. So really important to get that all right. Okay, with that, we have our roof and facade mission set up for our visual flights. And what we can now do is we can actually create a copy of each one of these. So we do a copy of the facade and we give it a name, facade thermal. And we create a copy of the roof and we give it a name, roof thermal. Now, why are we doing this? Well, we're doing this because we need to be able to create not just the visual flight plans, but we also need to create the thermal flight plans. So over here, I'm going to change the camera to Mavic 3 Thermal IR, and that's going to change the flight plan. So you'll notice the flight plan is a lot more dense, and that's because the thermal camera has different properties. Generally speaking, the sensor size and some of those properties are not as big as a visual camera, especially the resolution, and therefore all of those different things have an impact on how dense your flight plan will be. And so with a thermal camera, you still want to keep your flight plan at the right levels, but you will notice your GSD has gone up, which can be unavoidable given the constraints of a thermal camera. And you might want to play around with some of these parameters to get your images down, but if you can't, it's not the end of the world. So that's the thermal flight plan. So it's quite easy to do. And then we go to our facade thermal, which is again a copy from the visual flight plan. Go into our settings once again, and then we just choose Mavic 3 thermal. And we've got our thermal flight plan. So this is once again much more dense than the previous flight plan. But as you would hopefully recognize, you've got, you've got the same flight plan, but you've got it now with a thermal camera and about 200 images, which looks about right. So we've got all our flight plans. We've got 2 thermal flight plans and we've got 2 visual flight plans. So all we've got to do now is to download all of these flight plans onto our smart controller from DJI and fly them with the Hammer app. So the way this works is that you can essentially download the Hammer app onto the DJI Smart Controller. So Hammer Missions does support the DJI Smart Controller. And so as long as you're using one of the Enterprise drones, in fact, if you're using one of these drones, you can essentially download the Hammer app onto the Smart Controller for one of these drones. And then once you have the flight plan, you can actually sync this flight plan with your app on the DJI Smart Controller. So to go through the field workflow, we've got Dan on site near this hotel ready to capture the data. So I'm going to pass over to Dan and he'll take it from here.
Today we are going to capture this hotel using drones. We are going to do both the visual and thermal imagery using Hammer Mission. Not only are we going to capture the roof, but also the facade, so we can model the full building in one shot. Let's go!
Right, so thank you for all that flying, Dan. Must have been really interesting to capture that property with both visual and thermal camera. And so what Dan's done is that after he's captured all that data, he has essentially uploaded it back to Hammer Missions. And so we're now in the data analysis tab for Hammer Missions, and we've got a project, which basically is a project set up to model, map, and inspect this hotel. You can already see from the image over here that we've got some really decent looking images on the hotel. And so what happens now is that, as you will notice, you've got all of these different images that were taken by the automated flight plan using Hammer missions. And you can also see what that looks like on the map on the left-hand side. There's an image map for all of the different images that were taken. So if I was to click on any one of these dots, it would actually bring up the actual true condition of the property as captured by the drone. And you can already see, I mean, without kind of going any further, you can actually see the level of detail you get from drone data. And that's actually the power of drone data. I mean, if you just were to compare that with Google Maps, I mean, Google Maps really pales in comparison. You have no competition at all. Like, you can't see a bloody thing on Google Earth at all. I mean, you've got to remember that, even though both can create 3D models, the detail you will see with drones will actually allow you to make these data-driven decisions and help you inspect, maintain, and repair your property, as opposed to what you would sort of see with conventional data sources like Google Earth. Nothing against Google Earth. Google Earth is amazing, but just sort of saying that, you've got to have different things fit for purpose when it comes to inspection and maintenance. You've really got to rely on high resolution data from a drone. So what do we do next? Well, we've got all these images, and it can be a bit challenging to actually piece together what does the actual property look like. The first thing we've got to do is we've got to process all this data. So we click on process, and once you've clicked on processing, you can basically click on 3D model or 2D map and 3D model as an option, and then you hit process. And once you hit process, Hammer will go away and it will take a couple of hours, and it will actually generate a 3D model of this particular building. And so to save time, I've actually already done that before this video. So if I go into the 3D mode, voila, we have a 3D model of the hotel that we have just captured. And this 3D model actually is far superior to the 3D model that you see on Google Earth, just because it is so much more detailed and it is so much more real time with an updated condition that may or may not be visible on Google Earth. And so if I was to sort of whiz around this model, you will notice that all of the different condition related issues are already jumping out at me. If I'm looking at this as an inspector, I can sort of see that there are different parts of the roof. Let me make this bigger actually. I can already see that there are parts of the roof that are more stained than others. And there's something going on with some of these windows and all these stained brickwork with roof on the roof of the property. And that's something that we probably need to investigate. Also, we've got a visual picture of the secondary roof, which is visible here. So that's something that we will be looking at both visually and thermally. But going back to our kind of 2D or our smaller view of 3D model, what we have now is a 3D model. And if I wanted to understand, investigate any particular area of this 3D model in a bit more detail, what I can do is I can just click on that area. So let's say if I want to understand this sort of staining, and Hammer will bring up the closest image that actually shows that area. So this is the closest drone image that actually shows that particular area. And I can actually go in and I can use my polygon tool over here to actually mark up some of those issues. So it seems like, yeah, there's something going on here and there is some form of staining, and so I want to mark that up. So I basically mark that up, and that will now get saved on the platform as a note, as a tag, and Hammer will remember those particular tags that have been added. Equally, I can whiz around the model, and if I see other issues, so for example over here I see some form of staining once again, so if I click on that, a Hammer will bring up the closest image with all the details, and I can just click on the actual image and I can mark that up to see what is going on over there. So once again, click on staining, and that gets marked up and that gets saved in the platform. And this image already shows me there's something else also going on. I mean, there's all these bricks that are getting stained, and that probably isn't a good sign. So let me just quickly mark that up. Um, and I create any shape I want. So that's also really helpful because, I need to be able to follow the geometry of the issue and isolate it. And so I can actually do that. And once again, I see there's some form of moisture related issue around here. So I can just create my little shape, and I can give it a tag. So I can store all these different drawings or different markups on top of the actual roof, and then once I was to look at that on the 3D, I can actually bring up the image map. So I can bring up the images that have been captured. So these are the images that were captured. And if I just filter for the annotated images, I will now see the images that actually have an issue in them. So for example, these images that have changed color from yellow to orange, they indicate that there is actually an issue in each one of those images. And I can go in there and I can look at what is the issue. So I can just click on any one of these images and it will bring up any of the issues that have been highlighted. So that's a way to actually use the draw data where you're able to actually mark up and tag all of these different issues. Okay, so that's that on the visual side of things. What about the thermal side of things? So to be able to look at the thermal, we've got to go into the thermal project. So let's have a look at the thermal data now. Okay, and so now we're looking at the same building, but we're looking at a thermal scan and a thermal model of the same building. So I appreciate that maybe you're not able to see how this was created, but this is very much following the same process as we followed for our visual side of things, where we have a flight plan that was created to capture the top and to capture the sides of the model, and the roof and facade missions were basically executed on this property, and then all of that data was then stitched to create a thermal model by processing the data in Hammer Missions. So basically you upload all the data to Hammer Missions and you click on 3D model, or you click on 2D map and 3D model, and then you use thermal processing. Hit process, and voila, you've got a 3D model of the building in front of you. And you've not just got a 3D model, but you've actually got the ability to click on any part of this 3D model and then investigate the actual images. And as we actually saw, as we had an inkling, that double roof system, the second roof, actually does have something going on. If you look at all of these different patterns of variations in temperature, this just shows the level of moisture that's being retained by that roof, and that can be a bad sign. So just the amount of sort of temperature variation over here can be quite is quite alarming, really. And what you can not only do in Hammer Missions is not only just look at that temperature, but you can also click on the temperature icon over here and click on this particular feature to be able to actually look at what does the thermal what does the contrasting features actually look like. So you can actually adjust and scale the temperature to bring out some of those deficiencies in easier setting, because sometimes the contrast can make it really hard for you to see some of the heat and moisture sources. So if you really wanted to bring out some of those hot spots, which you can see they're coming out now, you can actually scale your temperature and then really bring out those areas of concern. So once you've got that, you can do this not only just in electric, but also in the jet side of things. You can change your spectrum, the different color palettes, so that you can actually bring out what are the different hotspots and different sort of anomalies that you might want to classify as deficiencies. You can sort of do this for different types of buildings, whether the buildings are in a pressurized condition or a non-pressurized condition. You can basically do this to be able to build an understanding for what does that particular asset actually look like, and what are some of the steps you might want to take. So that's looking at the data thermally, and once you've looked at the data thermally, you can once again create your annotations. So, if you were to find a particular area that looks like an area of concern, you can always go in and you can mark it up as an anomaly. And so you can do that in Hammer directly. Or you can also annotate the 3D model itself. So over here, we've got an annotation for the 3D model. You can give it an urgency level. So if you think something is really urgent, you can give it a high severity rating, and that's going to be saved in the platform for you as you're trying to investigate and essentially do the assessment for that particular building. So that's all to look at the thermal workflow. What about looking at the visual and thermal together? So this is where you can actually use the compare timeline feature for Hammer, where you're able to, once you've got both projects essentially organized in the same projects. So if you had, so if you were to look at that particular if you were to look at that particular building in more detail, you can basically put them in the same project. And what that does is that if we were to look at if you were to go back to a thermal project, you will notice that there is this sort of timeline for different projects. And so what you're able to do is you're able to actually compare and contrast by putting them side by side. And this allows you to actually see the visual and thermal data one right next to the other. And this is really important because sometimes we look at a thermal anomaly and you can't really tell what it is just by looking at the thermal data. What you really want to do is look at the thermal and visual data at the same time, because that builds a complete picture as to what is going on. So we're able to essentially look at visual and thermal for the same building, and we're able to identify any areas of concern, whether it's heat related concern or moisture related concern. And if you wanted to interrogate any area, so if we wanted to look at the second roof again, we just click on the model to bring up the relevant image. And you can do this both thermally and visually to once again, check it out and understand what is going on. Because all of these things, ultimately, there are tools that allow for better assessment, allow for better visibility of an asset, and to catch issues before it's too late, and to essentially recommend repairs and the right things for the end clients and customers to do, whether it's a property manager or a building owner. So, yeah, so that's basically how you would go about inspecting this particular building both thermally and visually. And this allows you to actually look at both thermal and visual models at the same time. And what's neat is that if you were to sort of move one model, the other one moves automatically, because that allows you to see how are things changing both visually and thermally. So that's the sort of that's how the visual and thermal modeling works, and that's how you're able to actually get the property in front of you so that you can actually do the inspection and understand how things work. Now, once you have done all of this hard work of analysis, why not capture all of your knowledge into an AI model and then use that AI model for your next inspection? And so this is where the power of AI comes in. What you're able to do essentially, as we conclude this video, is if I go back to the visual model for this particular property, as you might have noticed that the areas that were facing severe levels of staining, I had actually marked them up and given them a tag. So I had essentially said that we've got these different staining related issues. If I was to bring up some of those images that were tagged. So for example, I can see there are some tags in these images over here. If I was to click on this particular tag here and bring that up, so we should be able to see the image on the right and the model on the left. So we've got, for example, the tag here on the right, and we've got the model on the left. If we were to now look at quantifying, firstly counting, and secondly quantifying the level of staining on this building, how many stains there are, or what kind of area measurement do these stains represent, we can essentially create an AI model. So basically go to Spectre AI, we give it a name. So let's call this model something like staining. So we'll give it a name, stains, or let's say stains. And then we give it a description, staining model for hotel. Something like that, and then press the create button, and what this will do is that Hammer will go away and it will start creating AI models. So basically, we can create an AI model for all sorts of different deficiencies, different types of issues. It could be for corrosion, it could be for cracks, it could be for facades, it could be holes, it could be missing paint. And all these deficiencies, ponding mortar, terracotta crack, all these deficiencies can then just be automatically identified by AI on your project. Now, if you want to see a real life example of how that's done, we've actually covered that in a separate video that we released recently with respect to ponding water. If you want to understand how that AI workflow works, we would recommend watching that video to get a better sense of the whole AI workflow. So, thanks so much for watching. Hopefully you enjoyed watching this video and working through the thermal and visual inspection side of things with hammer missions. As always, we are very interested in learning what you think. So if you have any comments or thoughts, please leave them in the comments box below. And if you want to see more of these videos, please do hit the subscribe button, because we get really motivated when you want to see more videos, and we're very happy to sort of keep pushing out more videos for you to get a sense for where the drone data is today and how it can be used in a variety of different ways. Thanks so much for watching, and we'll see you in the next video for Knowledge Hub.